Hello everyone, welcome to Zero Labs. Today is Saturday, March 14, 2015. I'm Mark Brash, your host, and today is Pi Day. Does anybody know what Pi Day is? Well, the number pi, 3.1415927. Today is March 14, 2015, and at 9:27, it's Pi time. We'll have another Pi time this evening at 9:27 p.m., but on a 24-hour clock, Pi actually occurred at 9:27 a.m. this morning. Did you feel it? No, I didn't either. Oh well. I've been getting some requests on YouTube and on Twitter to provide a few more details about this little gadget right here for my rocket stove. It's the fire basket that I use for burning pellets in the rocket stove. I've been asked if there are any refinements since I first came up with this design, and I have a early version of the fire basket here with purely rounded corners, and this one has a slightly beveled corner that faces inward towards the horizontal burn tube. And since then, there really have been no refinements. The critical number on this fire basket is the spacing between the rods that make up the fire basket. They are 3/16 of an inch spaced apart. The pellets are 1/4 of an inch in diameter, so it's just smaller than the diameter of the pellets to keep them falling through immediately before they start to burn and then turn to ash. There are, however, some nuances to lighting it, and you can control the burn by positioning the basket in the opening of the burn chamber for the rocket stove during a burn cycle. So right now I'm in the middle of editing video for the 3D printer, but I do need to start up the rocket stove this morning, and I figured this is the perfect time to record this video for you so that you have an idea of how I go about lighting the rocket stove. Let's get started. Okay, the first thing that I do at the beginning of almost every burn cycle is I clean out the horizontal burn tube. So I'll just take my cover off the intake plenum, and I'm still just using these homebrew heavy mass wing nuts that I made. I could refine this a little bit further by putting a hinge on there and a latch, but this is still my first prototype, and it still has held up so well that I just don't see any need to go about doing that. It's not that big of an inconvenience. So I'm going to just scrape out the ash from the previous burn. Reach in here. Alright, this is the amount of ash that I've got from my previous burn of about, I want to say 2 to 3 hours. This is about 5 pounds worth of pellets reduced to ash. Okay, this little gadget that you saw me raking out the ashes with is a rake that I made out of coat hanger and a metal handle. I just taped it together. Nothing fancy, but I use this when the basket is hanging inside the burn tube. All right, I will reach down behind the basket with this rake, and I will come in underneath it and just slide it up in between the fingers of the fire basket, just to shake loose any ash that may have accumulated at the bottom of the fire basket. The softwood pellets have a tendency to accumulate ash. I have to do this probably once every half hour to an hour to free up the ash that builds up from the softwood pellets. Hardwood pellets seem to not suffer from that problem, so going forward I will only use hardwood pellets in this fire basket design. I'm going to take away this air plenum from the top of the burn chamber that Paul Wheaton over at Permies.com just discovered. I've been showing this for what, now 2 years? Some of you may have seen my tweet. Anyway, it's kind of funny. The basket simply sits in the opening, and I usually start with the basket all the way forward, sealing up the inlet so that the only place that intake air can get around the basket is underneath the pellets at the very bottom when I'm lighting. And then I will take the basket and I will slide it back about 3/16 of an inch so that I can see down the opening in front of the basket. I'll show you this in a minute after I light it. And what that does is it allows some air to enter the horizontal burn chamber ahead of the basket to allow the air to create the secondary burn that will occur in the horizontal burn tube and up the internal riser inside the main tank. Now you'll notice the basket literally hangs on the edge of the bricks that make the opening for the wood inlet. All right, and the way I made these tabs is they're adjustable. So you see I have them bent down just a little bit. All right, this is how I fine-tuned the height of the basket from the bottom of the burn tube to adjust the ratio of the air passing underneath the basket versus the ratio of the air actually passing through the basket and through the pellets into the horizontal burn tube. So this becomes part of the carburetor, if you will. All right, it becomes part of the mixture adjustment, and that's one of the things that allows the rocket stove to work the way it does. And that's one of the reasons that if you're just feeding sticks into this burn chamber, you end up having to jostle the sticks around every now and then to change the size of the opening, because as you feed wood into the opening of your rocket stove, you are literally restricting the cross-sectional area of the air entering and increasing the air velocity. You are essentially adjusting a carburetor as you go about doing that. So when you go about sizing your fire basket for the size of your opening in your rocket stove, you'll want to keep these factors in mind. Mine has a gap against the bottom about the thickness of my middle finger, so I can just pass my first knuckle touches the basket as I slide my hand underneath the fire basket, and that for this size opening is about the right ratio. That's something you're going to have to play with, and that's why I have these bends on the edge of the basket where it hangs on the brick, so that I can fine-tune the height inside and get the exact right air mixture when I'm in the middle of a burn. Right now I'm going to go ahead and put everything back together and load up the pellets in the hopper and let them start to fall in the basket. I've got a little tongue here that I insert into a slot in my gravity feed tube that prevents the pellets from dropping freely into the basket when I first load it. And for those of you who notice the copper wire loop, that simply holds the gravity feed in the center of the opening for the fire basket. Each one of these CD case covers, the 100 stack covers, holds about 2 pounds worth of pellets. So I put three of these in there. That's 6 pounds. That will raise the temperature of the workshop almost 30 degrees. All right, I'm just going to stick my fingers up in the opening of the gravity feed and release a measured amount of pellets into the lower section of the tube, and I'm going to reinsert the tongue to shut off the flow of pellets, and I'm going to allow that measured amount to just drop into the basket, and that's the amount that I want to start with when I light it. You'll notice that there are almost no pellets that have fallen freely through the bottom of the basket, even though across the bottom, because I have these loops staggered, and there is a 1/4 inch opening between the staggered loops at the very tip, there's still none of the pellets have fallen through. Only the ash comes through after it burns. Now here's where I do cheat a little bit. There are a number of ways to ignite the pellets. You can soak them with some barbecue fluid and light it. That has mixed results. I have tried taking cotton balls and soaking them in hot Vaseline or petroleum jelly and squeezing out the excess, letting them cool. I would set those on top of the little pile of pellets and light those and put the cover back on. That works reasonably well sometimes, but my ace in the hole, and yes, it's a fossil fuel, I'm sorry, but you know, propane torch works wonders lighting up pellets. All right, so I'm just going to start by lighting the very tip at the bottom. That's going to get an airflow started through the horizontal chamber and keep the convection going up the riser inside. Once I get the very bottom ignited, then I can work my way up the basket and continue to light the pellets from the backside until I get the whole first load here, the little ignition load, if you will, burning, and I'll put the cover on the front. You want to get them going good and strong before you put the cover on the front. All right, and as soon as I place this brick, the downdraft will immediately start pulling the flames downward in the burn chamber, across through the horizontal tube and up the riser inside. This is where having a heavy mass for your wing nuts makes it quick to reassemble. One of the reasons I haven't bothered to refine it any further, because this really is not that bad. Okay, so there's my first initial batch of pellets. I'm just going to slide this tongue back now. I'm going to allow some pellets to drop in to finish filling the top of the basket, and they don't overflow, obviously. Okay, give the feed tube a little bit of a tap. All right, the rest of them will fall down. I'll start the motorized agitator in just a moment. But here's the key now. Listen to the intensity of the burn. All right. I've got the fire basket all the way forward against the front wall of the burn tube, and I'm just going to take this and I'm going to slide it back 3/16 of an inch, and listen to the difference in the burn when I allow air to pass in front of the basket and mix with the gases and create the secondary burn. This is one of the little tricks you're going to have to learn, and every stove will be a little bit different, but I've got air passing behind it, underneath the pellets, and I've got air passing in front of it to enter the horizontal burn tube to assist in the secondary burn going up the riser. Very important. The only other thing you might want to do when you're initially lighting the stove, and I do this quite frequently, is I'll throw a couple of sticks in the basket behind the basket, let them sit in this part of the opening, and they will ignite from the bottom up, and they will keep a flame on the back side of the pellets for the first 10-15 minutes of your burn. They will accelerate the starting process, but I've got this thing going pretty good right now. I don't even think I need to do that. Now I could put this cover on top of my plenum if I don't want to hear the burn, okay? But I've got my outdoor air intake coming up through the floor right here, all right? And with the cover off, I can watch the progress of the burn, check for any ash buildup, etc. And the air entering really does not escape into the room. It literally exits, or comes in through that opening, that 3-inch opening right there, and circulates through the plenum and straight down into the burn chamber. So this cold air does not mix with the air in the room, and it provides the fresh air intake that the stove needs to burn. I love that sound. And it's just getting started. Last detail I want to show you is this little gadget right here. This is on the gravity feed tube from the hopper, maybe about 12-14 inches down from the inlet to the feed tube. This is just a little DC motor that I salvaged out of maybe an electric drill or something, and a hunk of steel bar with a hole drilled in it and glued to the end of the shaft to make an offset weight, and a little 555 timer circuit that I made that gives me about half a second on time and a variable off time anywhere from 30 seconds to 2 minutes. And I have it set, I think right now, for a minute to a minute and a half in between shakes. And this is the agitator that keeps the pellets flowing freely through here, because otherwise they do have a tendency to jam. The inside of this pipe is not perfectly smooth. There is a minor weld seam that sometimes will cause a clog, and all it takes is a tap on the tube to get them to free up and start flowing back down. But in order to allow this to run unattended, I simply have this little 12-volt battery up on the shelf. I don't even have a switch attached to it yet, and I'll just attach this wire to the terminal and you heard the motor shake. And in another minute and a half it will shake again and keep the pellets flowing freely down into the fire basket so that I can allow the stove to run pretty much unattended. And that's it. The process did take a little bit longer because I was recording this video. Start to finish, the process usually takes 5-6 minutes from the time I walk in to the time it's actually running by itself. Hope you've all enjoyed this video. As always, please rate, share, comment, and subscribe. Peace, everyone.